Bradley Teeman. This is my project for, I'm just comparing AI Pokébots. So basically, I'm using this PyPoker engine, which is just a Python library tool that allows me to have bots play poker against each other, basically. Um, and basically, all you have to do as the user, you have to create the bot yourself, or you can use a bot that was already created on here. And these bots will just be playing Texas Hold'em. So I've got three bots here. I've got Monte Carlo Tree Search, Q Learning, and Approximate Q Learning bots. The Monte Carlo Tree Search one I got from a blog called Data Blogger, and it was written by Kevin Jacobs. And it uses a tool that the PyPoker engine already provides, which is it will simulate the win rate for your cards that you have based on the community cards too, and that uses Monte Carlo simulation. And then what that does after that is it has a win rate output of that. So based on that win rate, it'll take an action. It'll either raise the max it can, raise the minimum, call, or fold. And then I've got a Q learning bot um, and approximate Q learning bot that has some features that I came up with, a couple features. So basically, each game you can set up the game. So each game starts out with 1,000 chips. Each player has 1,000 chips. The small blind is 20 chips. Um, so I set a max round per game to 10 rounds. So the winner of the game is declared after 10 rounds. So whoever has the most chips after 10 rounds wins. So each game had three players playing against each other. Uh, the three bots that I spoke about before. And then each game has like a log that's being built, and I added a couple more logs to get a better sense of how the game was flowing. So I had each game printed out to text file all the logs. Um, and then after I ran 5 games, I analyzed the results, and then I made some more adjustments, and then I ran 5 more games. So here's the results for games 1 through 5. All the settings are on the right. So these are the percentages of which the Monte Carlo tree search would make a decision on the action it should take. I've got some learning rates, discount rates, and epsilon for Q learning. And then my features for the approximate Q learning were to use win rate, and then I added one, and then based on the action it took, each action would have that action would have a feature based on what action it would take. So from the first 5 result games, I definitely Q Learning bot was the best player. He won the most rounds. He played the most rounds. But he was also the most aggressive, as you can see. Like he's the only one that raised. Um, but also the Monte Carlo Tree Search won a couple games, and I think it was because he tends to only play good hands or plays hands that he knows he'll win. So then the next 5 games, I adjusted some of the percentages here. I adjusted the learning rate discounts and some of the features of the Q learning bots. And then after those adjustments, I found that the Q learning bot was still the most aggressive and the better he won most games. But I did see the feature bot kind of get better and he was being more aggressive and won some rounds. But I still feel like the Monte Carlo tree search bot was the smartest, even though he played less hands. He just played like good hands. So my plan to finish up is to just continue to analyze the results I've gotten for the games that we played, and then also to finish writing my project paper. Okay, thank you for your time. Bye.